Our project is the automated Glockenspiel. The motivation for the project was to make a Glockenspiel that plays itself using an embedded system. We wanted to play a diverse set of songs over a somewhat wide range of notes and give the user control over what song was playing and when to play the music. We also want to convey to the user static and live data about the song, artist, and duration progress of the current tune being played. After developing our concept, we started making design decisions about how to approach the project. Our approach and implementation involved three different aspects. One part involved leveraging GPIO on the STM32 to trigger the solenoids. Another part involved interfacing the controller and screen with each other in the rest of the program. Lastly, designing a way to store the music data and coordinate it correctly with the timer on the STM32 also presented itself as a considerable technical challenge. Using GPIO to drive our solenoids involved getting around one roadblock. GPIO outputs a 3.3 volt logic level signal while our solenoids require 12 volts. So, in order to properly trigger our solenoids, we used relay drivers. The relay drivers, when driven with a signal from GPIO, act as a switch and allow the 12 volts from our power supply to flow through to the solenoids, allowing them to actuate. We used a TFT LCD display and an NES controller for our display and controller. SPI was used to communicate with the display. We implemented a finite state machine to implement the interface between the controller and the screen, with our states representing areas of the screen. For example, song name, play icon, pause icon, and tempo display all represented different states. The arrow pad on the NES controller was used to navigate the screen, and the A button on the controller is used as a select button and allows the states and the FSM to change. Now, after integrating our display with our system, we came about an unexpected problem. When we would send power to our solenoids and play music, our display would glitch out and our program would halt at times. Now, after much investigation, we realized that the 12 volts from our power supply were getting sent back to our board, and we needed a way to prevent this flyback. As a result, we used diodes to prevent this flyback in the relay drivers. Now, storing and playing the music properly through the STM32 was probably the most technically challenging aspect of the project. We wrote a Python script to convert the mini data of songs we wanted to play into a format of data we could work with on the STM32. On our 27-key Glockenspiel, each note was assigned to a unique GPIO pin. So our Python script encoded notes in the MIDI file to a 5-bit number. It also calculated the length of time from a particular note to the next note in a 15-bit number. So our song data stored in the STM32 was an array of 20-bit numbers that represented both a timestamp and an encoding for what note to play. Next, we configured a compared timer to trigger an interrupt when the delta T, or change in time, to the next note for each note passes, allowing us to trigger our solenoids. The results of the project went to plan. We were able to successfully play songs on our Glockenspiel at the direction of the user. Using the controller and display, the user can play, pause, and change the tempo of the song and see how far along in the current song the program is in a live loading duration bar you can see on the screen. The user can also change the song being played. We included 21 different songs, which are all stored on the STM32. Now, let us see some examples of us playing tunes on the instrument. We can navigate to a song we want by navigating to the top of the screen and going right on the arrow pad to the song we want, or going left on the arrow pad to the song we want as well. We then can press A, move down to the play icon, and press A again. Now the song starts. As you can see, the instrument plays quite well, with the notes sounding quite crisp and the song recognizable. We were very satisfied with the result.